Okay, we're looking at page 61 where we left off yesterday. If that's showing on the. Okay, guys. So we compared miles to leagues on the first page. Remember? So I want to give you a little hint right now. Everybody put your X and Y there. I want to give you well, not a little hint, a big hint. Guys, you're going to be finding the miles per league. So the miles per league. And we already did that on the other page, and we found the constant proportionality. Remember, we divided, or they divided for us, they were nice, and divided all the Y's by X's, didn't they? And it was all equal to 3. So, guys, look right here. This is important. This is where somebody's going to mess up in a minute. I hope not. But look, you're going to go divide 3 by 1, or they divided 3 by 1, 6 by 2, 9 by 3, and you get 3. That is your constant of proportionality, or your unit rate. Good job. Okay, so look down at the table. Okay. It can be, it's not going to be right now. Okay, you just divide it, and what you get is what you get. Okay, so on the next thing, we're going to compare the weight of the moon to the weight on Earth. The weight on the moon to the weight on Earth. So, this is our X and this is our Y. And somebody wanted to know earlier, how do you know which is X and which is Y? You just a minute. Now let's get started. Okay, so on this right there, this is your X, this is your Y. We're always going to put the X and the Y here. Okay? So, we're going to, they tell us, guys, that it's proportional because it says find the constant of proportionality. So what we're doing is we're finding K, and by dividing Y by X, you're dividing Y by X. Okay? So up here, we're dividing 1 by 6, and they reduced, but 1/6 is reduced. I don't know why they wrote it again, but anyway. And then 2 divided by 12, it's not always the bigger number on top. You're dividing the Y by the X. So 2 divided by 12 reduces to 1/6, reduces to 1/6, reduces to 1/6. So the constant of proportionality is 1/6. That's your K. So since that's your K, then we know we can write it in this form, Y equal KX. X is the weight on what? Earth. And Y is the weight on the moon. So just put M and E. And so 1/6 is the constant of proportionality. So look, they wrote the equation, Y equals 1/6X. All you have to do is find K, find the constant proportionality, and then go substitute it in for your K. That's all you're doing. Now look at the graph. Look at the graph. Now what we're doing is on the graph, what we're going to do is when you're looking at the okay, so we're looking at this, and we can tell it's proportional by looking at it. How can we look at the graph and know it's proportional? How can we look at it? And no, it's proportional. Okay. It goes through 0, 0, and it's what? Well, it has a constant. It has a unit rate. It's linear, guys. It's linear because it has a constant, a proportionality, and a unit rate. You're right. But we're just looking at it. If I'm just looking at it, all I'm doing is saying, oh, it goes through 0, 0, and it's linear. But because it goes through 0, 0, and it's linear, I know it has a constant of proportionality. Does that make sense? All of it kind of intertwines there. So when I look at that, I go, oh, that graph is proportional. So it's going to have a constant of proportionality, a unit rate. Okay? And I can write the equation y equals kx for that information. So look at the very bottom. On number 4, this is a relationship between the amount of time the backpacker hikes and the distance traveled. So this is your x, this is your y. This is your x, this is your y. So what does the 0.56 represent? 5 what? This is 5, 6. So 5 hours, very good. And then it's 6 what? Miles. So it's 5 hours, 6 miles. Now, I could use this one, which is 10, 12. I could use this one, which is 15, 18. I can use any of these that I want to do the next thing. Because I already know, what do I know looking at it? Tell me, what do I know looking at that graph? It's linear, and it goes to 0, 0, so it's proportional. So I already know it's proportional. So I already know that I can write it y equals kx. I already know that I'm going to write y equals kx form. But I'm trying to find k. Right, David? I'm trying to find k. So up here, I'm going to write k equals y over x. Y equals k over x. Y equals k over x. I mean, k, did I say that right? K equals y over x. So give me a y. Give me a y. There's no y that's 10 over there. 12. And look, guys, I'm gonna make it easy for everybody. Let's use the lowest number. Let's just don't pick a random number. Let's use 6. Guys, this is your x, this is your y. This is your x, this is your y. So I'm going to put 6 over 5. That's the biggest mistake that's made. Guys, y'all know that this is the x coordinate and the y coordinate, correct? So it's going to be 6 over 5. So y equals 6/5 x. Now think about it just a minute. We did the miles by the hours. We did the miles by the hours. You're not going to do the hours per mile. That sounds silly. No. Does everybody understand what we just did? Okay, look on page 62. Read that first sentence for me, Jay. Okay, so it is or is not constant? No. Now, wait a minute. Yes, it is constant. Good. Because, remember what I said? If it's linear, goes through 0, 0, it has a constant of proportionality. So it's going to go up the same every time. So it is constant. Very good. So what do we call that K? What is K called? Constant of proportionality. Divide it up. It's a long word, but if you divide it up, you can spell it. Proportionality. Okay? So, it says write an equation that describes the proportional relationship. So, they're telling us, guys, hey, it's proportional. They didn't give us the graph to look at, but they're telling us, hey, it's proportional. So, we know that we can write this equation down here in y equals what? Kx form. So we've got to go find what K is. That's our mission right now, is to go find K. Because it's proportional, we can write it in this form. So I'm trying to go find K. I come up to my table. 1 is 7. What's 2? 4 is 28. 56 days is 8. And 10 is good job. So, X is the week. They're both time. They're both time, people. So X is the weeks and Y is the days. So to find K, what am I going to go divide? Y over X. So give me one. 7 over 1. And 7 over 1 is 7. So your K is 7. So just go fill it in. Substitute it in for K. Does everyone see why it has to be 7 over 1? Y divided by X. Okay? Now look at y'all been talking about atoms in science. Look, it tells us again it's proportional. So we already know what we're going to have to write it in. Y equals Kx form. So let's fill out the table. What goes here? 10. 17. Thank you, people. They got 17. 120 is good. Daniel. Now, so we're going to go find K. Y over X. Y over X. David? So we're going to go 4 over 2, which is what? 2, which is your K. Does everybody see where we got K? You could have divided 10 by 5, 34 by 17, but let's use the smallest one. Let's use the smallest one. So K is 2. So we're going to get so Y equals what? 2x. Y equals 2x. Okay? Now, I want everybody to do number 5 just like we did number 4. It's proportional. Look, guys, it's proportional. Right? How do we know? Goes to 0, 0, and it's linear. Go. Find K like we did on number 4, and then write the equation. Okay, guys, what'd you get for K?
38.
No, not for K. 30 over 1, which is 30. So K, yeah. So K is 30. The constant proportionality is 30. Then you go write y equals 30x. Good job. Good job. Now you could have used, this is 130, this is 260. You could have used any of these. Okay. Okay, yes. So number 6, if you know the equation of a proportional relationship, so you know the equation, how can you draw the graph of the equation? So the proportional is going to be y equal kx. That's what it's going to look like, the equation. How are you going to start drawing it? Start with who said 0, 0? Good, good. Start with, and let's put the origin. Let's use the algebra word. Start with the origin, and then what? Make it linear. You're going to start with the origin. There's going to be a point that goes to the origin, then you're going to make it linear. Okay? Look at the next page. Page 63. Okay? Look at this table on page 63. Is this relationship proportional?
No.
How do you know?
Because 0 times 32 is 0.
Well, it doesn't go through 0, 0, right? It doesn't go through 0, 0. So no. It doesn't go through, hey, let's put origin. Let's make it algebraically sounded. Okay? Guys, I want to ask you something. If the 032 was not there, 032 is not there, how could we go, that doesn't mean it's not proportional, but how could we go find out if it is proportional or not? Okay, Logan.
Yep. So 50 divided by 10 is 5.
So we're going to find our K, right?
Yes.
So 50 divided by 10 is 5. There you go. So 50 divided by 10 is 5, but 68 divided by 20 is not 5. So I get that? So we know it's not proportional that way too. That's another way we're going to have to determine. Okay, good deal. Okay, go back down, go down to 9. Raise your hand when you know this. Ralph opened his savings account with a deposit of $100. Every month after that, he deposited 20 more. I want the equation. I want the equation to find out how much he has in his account. Why? What would the equation look like? He started with 100 and he deposited 20 every month. Trent? No. Good. And I'm going to write 20x plus 100. Good job. So, x is the months. So, 20 times the months plus 100. Guys, we've been working on problems like this. Y'all done ones harder than that. Deposit of $100, and they added 20 a month. Right? Okay, so why is this equation, why is this not proportional? It starts, exactly what I want you to say. It starts with, good work, it starts with $100, not $0. Good job. Okay, close your book. Okay, on the front of this, just the front, I want you to look at the graph, and we're going to fill in the table. Okay, so we're going to put X, Y. We're going to put X, Y on the table. You're going to use the table, the graph to fill in the table. Go do that real quick. Go. Fill in the table. Okay, what you start with? I was hoping you start with 0, 0. Okay, 115. If you didn't, don't erase. Don't erase. So 115, 230, 345, 460, and then 575. As long as you have some of those, that's what I need. You need to have some of those numbers. Okay, now we're going to have to write the equation down here. So what do we, oh wait, I forgot to say something totally important, ask you something totally important. Is this graph proportional? Yes. So we know there is a constant of proportionality or unit rate. So right here we're going to put K equals Y over X. Go find K for me and then go write your equation. God bless you. So what'd you put? 15 over 1, which is 15. So what's my equation? Y equals 15x. Okay, now we need to find the situation that will go with this graph. Now, this is a continuous graph. It's continuous. So we have to pick something to put down here for the x. This is our x, that you can divide up. So it can't be children. It can't be animals. We could do miles. So for miles, well, no, well, if we did miles and leagues, remember there's 3 leagues in a mile, so we can't, it's got to be something that's 15. So we can divide time up. What, Trent? Car parts, okay. 15, we could do $15 for each. Well, but you can't divide a car part up. You can just have one car part, like one battery, 1 minute. Okay, what about hours? What if we do hours? That right here. Hours, but what could the 15 represent? No, there's not 15 seconds in an hour. Y'all are trying to make it way too complicated. Well, no, we can't do hours and minutes because there's not 15 minutes per hour. I'm not trying to, look guys, I'm not trying to convert anything. Guys, let's do 50, somebody got a job and made $15 an hour. Okay? Who do you want to get a job? I'm going to put Bob. Okay, Bob made what? $15 an hour. What represents the hours? Over here. Which one's the hours? X. So X is the hour. So Bob made $15 an hour, X. And Y is the what? Total. Well, no, X is the hours. It's the total he made. We'll say that. He got paid is what. So Bob made 15 an hour, X, and Y is the total he made. So X is the what? X represents the what? Hours. And Y represents the total money made. What does 15 represent? It didn't say for that, but what does 15 represent? There you go. It's the money per hour. Money per hour. So now we're going to go put that on the table. So we're going to put, the graph. So you've got hours down here and total. His total. Just put. Does that make sense? Because he can work for 1 1/4 hours or 2.5 hours or whatever. He can work that. Okay. Oh, sorry. Okay. Turn on the back. Now this time they gave us the equation, guys. X stands for the gallons and Y is the total cost. X is the gallons, Y is the total cost. So what we need to do is come up to the table. This is my equation. Hey, by looking at the equation, is it going to be proportional? Is it in Y equal KX form? Yes. And what's K? Yes, it's going to be proportional. So y'all want to start with 0? Let's do 0, 1, 2, 3, and 4. Find the values for Y, and then we're going to go graph. And guys, you only need to graph 3 of the points. Go. Let's go. Find the values for Y. That's the equation. 2.25x. just need to graph 3 of the points, remember. Okay, so we'll check this tomorrow.